Hello student, welcome to the another session of Computer Networking and Security. This is Vasant Nayak from Canara Engineering College. In this session, you will study hierarchical routing. So what is actually hierarchical routing? What do you mean by autonomous system? What is intra-AS routing protocol? What is inter-AS routing protocol? And what is the gateway router? All these things we will study in this session. So students, in the previous session we studied link state routing and distance vector routing. The other way is around global routing and decentralized routing. So the one more classification routing is hierarchical routing. What was the problem with then link state routing or this one dynamic link state routing or distance vector routing? Actually, the problem is scalability. As the number of routers becomes large, the overhead involved in computing, sorting, and communicating routing informations to the other routers and sending the update about the least cost path becomes somewhat cumbersome. Then second thing is administrative point of view. Some organization requires administrative autonomy. So in order to consider both of these problems, so this research team came up with one more solution, that is organizing the router into autonomous systems. So now what is autonomous system? A autonomous system consisting of group of routers that are typically under the same administrative controls. For example, particular organization with the different branches across India, they will come under particular autonomous system where they can apply their own rules, regulations, and policy in their autonomous system. So routers within same autonomous system can all run with the same algorithm. For example, either all the router will run a link state algorithm, or all the router will run a distance vector algorithm, and have information about each other routers exactly as with the what we studied in the previous session. The routing algorithm running within the autonomous system is also known as intra-autonomous system routing protocol, intra-autonomous system routing protocol, intra-AS routing protocol, or it is also known by the other name, that is interior gateway protocol, IGP protocol, interior gateway protocol. So routers in different AS can run different intra-AS routing protocol, but how finally you connect different different autonomous system? For that we have one more protocol, that is called as exterior gateway protocol, EGP. So exterior gateway protocols are used to connect two different autonomous systems, or it is used to connect multiple autonomous systems together. Now students will consider this this scenario. In this scenario, or in this diagram, you can see three autonomous systems are there. So autonomous system 1, autonomous system 2, autonomous system 3. Autonomous system 1 has got 4 routers with the different subnet connection. It is shown here. That is 1A, 1B, 1C, 1D. Autonomous system 2 has got 3 routers with the different subnet connectivities, and autonomous 3 has got 3 routers. Now, other than that, please here you have to note one more point, that router 3A and router 1C in autonomous system, and router 1B in autonomous system 1, and router 2A, that is, let me repeat once again, router 1C, 1B, 2A, 3A are called as gateway routers, because these routers will connect two autonomous systems. So you have to know here that the protocol which works inside the autonomous systems are called as intra-AS routing algorithm or intra-AS routing protocol, like IGP, example for RIP OSPF, RIP OSPF. All these protocols, RIP OSPF will update the routers with the topological changes or other changes. And these because of this routing algorithm, router will compute the routing table and it will update the routing table. Now as I said in the earlier session, each autonomous system can run either link state or distance vector protocol. Now the question comes, depending on this protocol, each router will compute routing table or forwarding table, and each router knows to which link or which router it has to forward the packet to reach within the particular autonomous system. Now the question comes, suppose the router in AS1 wants to send the packet to the router in AS2. Then this is a inter-AS communication. This is a inter-AS communication. That is, router in AS1, autonomous system 1, wants to send the packet to router in autonomous system 2. Here, this router in autonomous system 1D has to first send the packet to the gateway router. It has to decide the gateway router to reach the autonomous system 2. It has to decide which is the gateway router to reach the autonomous system 2. In this diagram, the gateway router is 1B. To send the packet to gateway router 1B, which is the least cost effective path, that has to be determined by the router 1D based on the routing table. So based on the routing table, router has to decide which is the best path to send the packet to the gateway router, that is 1B. Either it can follow this path, or it can follow this path. So which is the best path to send the packet to the gateway router? Once the packet reaches the gateway router will forward the packet to the gateway router of the other autonomous system by using EGP and exterior gateway protocol. Then the packet will delivered to the destination router in the particular autonomous system. So consider this scenario here. Suppose the router in AS1 receives the datagram which is destined outside of AS1. The datagram may be destined to AS3 or AS2. Now which gateway router this router has to forward the datagram? For example, suppose to reach AS2, 1B is the gateway. To reach AS3, 1C is the gateway. That means AS1 has to learn which destinations are reachable through AS2, which destinations are reachable through AS3, and propagate this information to all the routers in this autonomous system. If it is feasible, then the particular router can send the packet to the concerned gateway. I mean, to send the packet to AS2 autonomous system, AS2 router ID can send the packet to IB. ID can send the packet to router 1D can send the packet to 1B. 1D can send the packet to 1B. Similarly, router to send the packet to the autonomous system 3, router 1D can forward the packet to 1C. Now suppose the packet is destined for autonomous system 3, then router 1D has to forward the packet to 1C. In order to forward the packet to 1C, you can see there are different paths. The path can be through 1D, 1B, 1C, or 1D, 1C, or 1D, 1A, 1C. So which is the better path? This has to be decided by the router 1D. Which is the better path? This is decided by the router 1D using interior gateway protocol. So by using interior gateway protocol, to reach the gateway, router will decide the best effective path, best low cost effective path. It will decide the best low cost effective path to reach the gateway. For in the diagram here, to reach the gateway 1C, the best effective path is 1D to 1C rather than 1D, 1A, 1C rather than 1D, 1B, 1C. Now in this scenario, you can see, suppose AS1 learns via inter-AS protocol. I have told in my previous video like what is inter-AS protocol and what is intra-AS protocol. Intra-AS protocol means IGP, inter-AS protocol means EGP, Exterior Gateway Protocol, the protocol which works between different autonomous system. So the protocol which works between different autonomous system is called as inter-AS protocol. The protocol which works inside the autonomous system is called intra. So now AS1 learns via inter-AS protocol, of course, that subnet X can be reachable through AS3. Now, so reachable through AS3. So ASBR 1C router learns about subnet X that can be reachable through AS3. Now router 1C passes that information to all the routers through Interior Gateway Protocol, IGP. It will pass this information to all the routers. Now all the routers will come to know that to reach subnet X, it has to forward the packet to gateway router 1C. So all the router will now decide the shortest path to reach the gateway router to reach the subnet X. So, and it will do the automatic changes, respective changes in the routing table. All the router will do the respective changes in the routing table to reach the destination X. Now we will see the one more scenario. Now compared to previous slide, now in this slide, AS1 learns that to reach the subnet X, there are two paths exist. One is through AS3, second one is through AS2. That means AX is reachable via AS3 or via AS2. Now this is the job of the inter-AS routing protocol, to decide which is the best path to reach the destination, X from AS1, whether the best path is through AS3 or through AS2. So, and that information will be passed to the other routers in the AS1. Now AS1 has to update the routing table to reach the destination X, whether it has to send the packet to the gateway router 1C, which will connect autonomous system 3, or gateway router 1B, which will connect autonomous system AS2. So this is the job of the intra-AS routing protocol. The first job of the inter-AS routing protocol is the inter-AS routing protocol has to decide which is the best path to reach the subnet X via AS3 or AS2, and in case AS2, and that information has to be passed to the other routers, and other router has to decide which is the best path to reach X via 1B or 1C, whether it has to send the packet through 1C or it has to send the packet through 1B. When there is a multiple path exists to the autonomous system, so when there is a multiple path exists to the particular subnet or autonomous system, then the router, it depends on the entirely the router or this one interior or intra routing protocol, intra autonomous system routing protocol, to decide which is the best path to send the packet to the destination. For example, suppose AS1, in the last diagram, AS1 learns from the inter-AS protocol that subnet X is reachable from AS3 and AS2, as we saw. To configure the forwarding table, router 1D must determine towards which gateway it should forward the packet to the destination, that is gateway C or gateway B. So this is also job of a inter-AS routing protocol. Once this is done, so this is also job of inter-AS protocol, and this is also known as hot potato routing. So sending packet towards the closest of two routers. This is called as hot potato routing. So here you can see, learn from the inter-AS protocol that subnet X is reachable via multiple gateways. Once it is found multiple gateways are there to reach the particular destination, then use routing info from intra-AS routing protocol to determine the least cost path to reach the gateway. Then hot potato routing choose the gateway that is the smallest least cost path, and after that determine from forwarding table which is the interface that leads to the least cost gateway path to reach the destination. This is called as hot potato routing. So as I said, intra-AS routing protocols are one more name for the intra-AS routing protocols are called as IGP, Interior Gateway Protocols. So this protocol works inside the autonomous system. So the example for the intra-AS routing protocol is one is called a Routing Information Protocol (RIP). Second one is called as a OSPF, that is Open Shortest Path First Protocol, and third one is called as a Interior Gateway Routing Protocol. This is a Cisco proprietary protocol designed by Cisco system, and it works on most of the Cisco device. So first protocol we will see, that is RIP, Routing Information Protocol. So the important point related to Routing Information Protocol is one is it is included by Berkeley System Design Unix distribution in 1982. Then it is a distance vector algorithm. It makes use of distance vector algorithm. We know what is distance vector algorithm, and it makes use of matrix ops. There are different matrices used by the different protocols like bandwidth, then cost, delay, etc. So the RIP makes use of this op count, and maximum op count is 15. After that, link will be defined as unreachable. So distance vector routers exchange information with the neighbors every 30 seconds. That is, each router will send the advertisement about its routing table to the other router 30 seconds. Each advertisement lists up to 25 destinations, that is subnets and IP address. From the diagram you can see router A to destination subnets U to the destination subnet U, it is 1 hop away. Similarly, V, it is 2 hop away, then W, it is 2 hop away once again, X, it is 3 hop away, Y, it is 3 hop away, Z can be reached like this or like this also, but this is the best path, so it is once again 2 hop away. So like this, each router will update routing information every 30 seconds, and it will update the routing table. So here you can see example of routing table constructed by RIP protocol. So if you consider the router D, routing table in the router D, for router D, destination subnet is a destination subnet W, and to reach the destination subnet W, it has to go through A, and it is 2 hop away. Similarly, to reach the destination subnet Y, it has to send the packet through B, and it is also 2 hop away. And similarly, to reach the destination subnet Z, so next router is B, but the Z is after like to reach the subnet Z, it is 7 hop away from the router D. So in this way, RIP will construct the routing table. So RIP will send advertisement of the routing information, or it will update the neighboring routers every 30 seconds. Suppose if the router, if the particular router, if no advertisement heard after 180 seconds, then what the router will do is, the router will declare that particular link or neighbor is dead. So normally routes are sent via neighbor, so it will declare the particular neighbor is dead, and a new advertisement is sent to the neighbor every 30 seconds. Neighbor also in turn sends the new advertisement. So here only thing is, problem is link failure. The convergence of the link failure is not faster compared to link state protocol. So it is slower, and here in order to avoid the looping, what we call is ping pong loops or infinite loops. Once the router is away from 16 hops, once the particular destination is away from 16 hops, then that route is decided as a infinite loop. And in order to avoid the infinite loops, it will make use of the technique called as a Poisson reverse. So before we conclude, RIP actually RIP protocol comes under actually application layer of the OSA model or DoD model. So RIP makes use of UDP protocol under transport layer. Advertisement is sent by using UDP packets periodically. So RIP routing tables are forwarded by actually managed by application level process called as daemon. So with this we will conclude this session. So in the next session we will see one more protocol that is called as open system path first protocol. So we will see that one in the next session. Thank you.